In this video, we're going to look more at the ambiguous case of the law of sines. Recall this occurs when we have an angle opposite side pair and an additional side. It is for this reason it is sometimes referred to as the angle side-side problem. Caution must be taken when solving the angle side-side problem, as there are sometimes 0, 1, or 2 triangles that can be formed with the given information. To determine which it is, we'll have to consider 2 cases. Depending on whether the given angle is an acute angle between 0 and 90 degrees, or the given angle is an obtuse angle between 90 and 180 degrees. Let's first consider the case where the given angle is an acute angle. And let's still assume that we have an angle opposite side pair, alpha and A, and additional side B. If we had been given a different angle opposite side pair, like gamma and C, I would have placed gamma in this location, and my argument would have been similar. Now, since angle alpha is an acute angle, my picture will have to look something like this, with the opposite side A being over here. Now, we don't draw side A yet since we're not really sure where to put it. Does it come straight down and touch this side? Does it pivot towards angle alpha? Or does it pivot out this way? Well, since we're not sure, we won't draw side A yet. But we still have side B. And since we know the length of side B, let's place it here adjacent to angle alpha, so that side C would be down here. And since its length has not yet been determined, let's put an arrow on here to remind us that we can change the length of side C if necessary. Now, to determine how many triangles can be formed with the given information, we're going to construct a reference height, which is formed by dropping a line straight down from the top of B. Notice that this reference height H forms a right triangle with angle alpha, so that we have the sine of alpha can be written as the opposite side, which we have as H, over our hypotenuse, which we're referring to as B. Now, we can solve for our reference height H and write it as B times the sine of alpha. And I claim this reference height is all we need to be able to determine how many triangles can be formed with the given information. If the given opposite side A is less than H, then when it hangs down from the top of B, it's not long enough to reach the next side, so that no triangles are formed. If the given opposite side A is the same as our reference height, then one right triangle will be formed. If the given opposite side A is longer than H, but shorter than B, let's pause. What will that look like? Well, if A is longer than H, then it's going to hang down below C. Not so long, though, that it's longer than B. So that if I were imagining pivoting A like it were a pendulum towards the left, a smaller triangle could be formed. While if we pivot A to the right, maybe a larger triangle can be formed. Again, if side A is just the right length, where it's longer than A, but not longer than B, then 2 triangles can be formed. Lastly, if side A is longer than H, and longer than B, so long that when I pivot side A to the left, a smaller triangle cannot be formed. This is going to happen if A is ever longer than B, even just a little bit. However, we can still pivot side A outwards to make a bigger triangle. So that if side A is longer than B, a single triangle will be formed. Now, of these 4 scenarios, the first one, the second one, and the fourth one don't cause a lot of problems. But this third scenario, where 2 triangles can be constructed, this deserves a little bit of attention. Let's look at it more closely. Again, let's say we're looking at the problem where two triangles can be formed. This occurs when we have an acute angle and the given opposite side is longer than the reference height but shorter than the other given side. Again, this is the scenario that side A, when it's dropped straight down from B, would be longer than the reference height. If you swung side A to the left, you'd get this smaller triangle, while if you swung side A to the right, you'd get this larger triangle. It's important that when we have this two triangle case that we always solve the larger triangle first. Notice that I have labeled the rest of the angles and sides using our convention. Now, since we have an angle opposite side pair, alpha and A, we know this is a law of sines problem. And since we have a side B, we can use the law of sines to find this angle beta 1, using the ratio that the sine of alpha over A will have to equal the sine of beta over B. And so that angle beta 1 can be found. Then, using the angles tool, we know that these three angles will always sum up to 180 degrees. We can say that the angle gamma 1 can be found by looking at 180 degrees minus alpha minus beta 1. So that now this angle is known. And once angle gamma is known, we can use the law of sines to find this other side C, and so that all parts of this triangle can be found. Now that we've solved for all the angles and the sides of this bigger triangle, we move to the smaller triangle. To do this, we observe that this angle beta 1 in my picture is the same as this angle right here. Beta 1 is part of an isosceles triangle formed by these two red sides. And since these two sides are the same length A, this angle must also be beta 1. So that this angle on the outside here will be beta 2. Since beta 2 is a supplementary angle to beta 1, we can find angle beta 2 by looking at 180 degrees minus beta 1. So that for the smaller triangle, beta 2 is now known, and we can fill that in our table. Again, by the angles tool, since we know alpha and beta 2, we can find that gamma 2 will have to be 180 degrees minus alpha minus beta 2, so that this angle gamma 2 is also known. And we could use the law of sines to find side C2. Again, it's important in this problem to realize that we first must solve the bigger triangle and then use that information to solve for the smaller triangle. Let's move on to the second case that we had to consider. If the given angle is an obtuse angle that's between 90 and 180 degrees. And let's still assume that we have an angle opposite side pair alpha and A, and additional side B. Now, since angle alpha is an obtuse angle, its picture must look something like this, with its opposite side A being over here, and our additional side B, let's place it right here. There are only two possibilities we have to consider for this obtuse problem, depending on whether the given side A is longer than B or not. If A is not longer than B, if A is not long enough to reach to this other side, then no triangles can be formed. While if side A is longer than B, then it is long enough to reach this other side. Depending on how long B is, we may get a longer triangle here. But we do come up with a single triangle. Now, this does complete my look at the ambiguous case of the law of sines. I encourage you not to memorize this, but to see the construction of the argument and draw the picture. It will be clear how many triangles are possible with the given information. I hope this is helpful, and I'll see you next time.